simple T equations. T is nothing but the trigonometric equations. And the first is sine theta is 0. According to your general knowledge of trigonometric values, whenever you see a trigonometric table, in that, what will be the theta value if sine theta is 0? We'll say theta is 0, right? Because we have seen the just the basic values for 0 degrees, 30 degrees and all. So if sine theta is 0, we basically tell that theta is a 0 degree. So, but now here comes the reality is for equation sine theta equal to 0, there are infinite number of solutions. Not only 0 degrees, there are other solutions for this equation. So let's see how this actually happens. So this is a sine theta graph or sine x graph in which 1 is the maximum value and 0 is the minimum value. So in this graph you can see where this sine theta is touching the x-axis. Like for what values of theta you are getting 0 value. For 0 degrees you are getting 0 value. For pi degrees you are getting 0 value. For 2 pi and so on. And in the negative direction, similarly, you are getting minus pi, minus 2 pi, and it continues. Okay. So here we can see there are so many infinite solutions for sine theta equal to 0. But we generally know that it's only a 0 degrees. But there are n number of solutions, that is n pi, where n is nothing but the any integer. See, pi is a solution if if n is 1, then theta becomes, according to this formula, theta becomes pi, which satisfies this, right? So when theta is pi, sine theta is 0. Similarly, if n is 2, theta becomes 2 pi from this equation. It's satisfying. Like on this, you can, in this graph, you can see when theta is 2 pi, sine theta is 0. So similarly, if n is minus 1, the negative numbers, theta becomes minus pi. When you substitute here n as minus 1, you'll get minus pi. So when theta is minus pi, sine theta is 0. Similarly, for n is equal to minus 2, theta becomes minus 2 pi, and here also at this value, sine theta is 0. So now onwards, you should say if sine theta is 0, theta is equal to 0. It is just a one solution, but it is not the always correct solution because we have just seen that for this kind of equations, we have infinite solutions. Now onwards, the solution for theta is nothing but theta is equal to n pi. Here, n is nothing but the any integer. Okay. So second, sine theta is equal to 1. For this equation, when you see this kind of equation, the first value of theta which strikes your mind is theta is 90 degrees, or else in radians it is pi by 2, because these are the basics, or these are the values which we have learned from a trigonometric table, right? So when we see sine theta is 1, the pi by 2 is the value which strikes our mind, right? But actually, it is just one solution of this equation. It also has infinitely many solutions. Let's see how it is. So this is the graph of sine x or sine theta. Here you can see when the value is 1, what are the values of theta? At pi by 2, at here, pi by 2, value is 1. Similarly, again at 5 pi by 2, the value is 1. We are talking only about 1, not minus 1. Okay. And in the negative direction, value is 1 at minus 3 pi by 2. I hope you are getting right. So the basic one is pi by 2, which we all remember. And you can see if you calculate the difference between these two, 5 pi by 2 and pi by 2, you will get 2 pi as the difference. Similarly, if you calculate the difference between minus 3 by 2 and pi by 2, you will also get 2 pi as the difference. So, one thing you can note down here is it becomes 2n pi plus pi by 2, where n can be the any integer. So, this becomes the solution for the theta. Let's verify this. If n is 0, if n is 0, theta is nothing but pi by 2, which is a basic solution. So if n is 1, theta becomes 2 2 pi plus pi by 2, which is nothing but 5 pi by 2. Here only we have seen the solution, right? Similarly, if n is minus 1, it becomes minus 2 pi plus pi by 2, which is nothing but minus 3 pi by 2. So it satisfies, this equation satisfies our values. So if you take LCM over here, you will get the value of theta, or you will get the solution for the theta as theta will be 4n plus 1 pi by 2, where n is nothing but all integers. If you take LCM from here, that is 4n pi plus pi whole divided by 2. Take pi common, it becomes 4 and 1 pi by 2. This is what I've written here. So if sine theta equal to 1, the solution of theta is 4n plus 1 pi by 2, where n belongs to all integer values. If sine theta equal to minus 1, then what is the value of theta which strikes your mind immediately? It is minus pi by 2, right? Because we have seen the basic trigonometric table, and these are the values we have known earlier. But this is this, but it is just the one solution for this equation, because there are infinitely many solutions for these trigonometric equations. So let's see how it is. So this is the graph of sine theta. Here, for what values of theta, the sine theta becomes minus 1. You can see the basic thing, that is at minus pi by 2, sine theta is minus 1. Similarly, at 3 pi by 2, sine theta is minus 1. Again at minus 5 pi by 2, sine theta is minus 1. So if you calculate the difference between all these, you will get 2 pi. How you will calculate the difference? Just subtract it. Like minus pi by 2 minus of minus pi by 2. It becomes plus pi by 2, that is 4 pi by 2, which is nothing but 2 pi. So the difference between these two is 2 pi. Similarly, the difference between these two is also 2. pi. So we can write theta as 2n pi minus pi by 2. Minus pi by 2 is the one which we already know, right? Where n belongs to all the integers. If n is 0, the theta becomes minus pi by 2, which is the basic solution. And if n is 1, theta becomes 2 pi minus pi by 2, which is nothing but 3 pi by 2. Similarly, if n is minus 1, theta becomes minus 2 pi minus pi by 2, which is nothing but minus 5 pi by 2. So from the graph, we have seen the values and we could verify this by using this solution. So we can write the solution for the theta as, now the solution for theta is 4n minus 1 into pi by 2, where n belongs to all integers. When you take LCM from here, you will get this solution. But you can also get a doubt. For this solution, we have taken theta equal to minus pi by 2 as the basic one. But if theta is 3 pi by 2, let's take the basic one. Then the solution becomes 2n pi plus 3 pi by 2, where n belongs to all integers. So let's verify this also. If n is 0, theta becomes 3 pi by 2, which is the correct solution. If n is equal to 1, theta becomes 2 pi plus 3 pi by 2, which is 7 pi by 2, which is also a basic solution. Like if you calculate the difference again over here, 3 pi by 2 plus 2 pi, you will get 7 pi by 2 later. Similarly, if n is equal to minus 1, theta becomes minus 2 pi plus 3 pi by 2, which is nothing but minus pi by 2, which is the solution we have seen. So this also satisfies sine theta equal to minus 1. So the another solution for theta is 4n plus 3 into pi by 2, where n belongs to all integers. So for sine theta equal to minus 1, this might be a solution, one solution, and this might can be a second solution. Whichever solution you take, the answers you're gonna get are the same. So it's okay if you take any solution from these two. Next trigonometric equation is cos theta is 0. So when we see cos theta is 0, what is the value of theta which strikes your mind? Theta is pi by 2, right? This is the value which strikes our mind because we have seen these values only in the trigonometric table earlier. But I already told these kind of equations have infinite many solutions. In that, this theta equal to pi by 2 is just a one solution. So this is the cos x or cos theta graph in which all the theta values are on the x-axis and 1, 0 and minus 1 are on the y-axis. So at what values of theta? Cos theta is 0. Here at pi by 2, we know the cos theta is 0. And from the graph, we can see that at 3 pi by 2 also, the value is 0. And also 5 pi by 2, the value is 0. Similarly, at minus pi by 2, the value is 0. Minus 3 pi by 2, minus 5 pi by 2. For all these values, cos theta is 0. So from here, we can write the solution as n pi plus pi by 2, where n is nothing but it belongs to all integers. Let's verify this. If n is equal to 0, we can write theta as pi by 2. And this solution we already know. So similarly, if n is 1, we can write theta as pi plus pi by 2, which is nothing but 3 pi by 2. So this is the solution we have seen. If n is 2, we can write theta as 2 pi plus pi by 2, that is 5 pi by 2. So this is also a solution. Now let's take the negative values. If n is minus 1, theta becomes minus pi plus pi by 2, which is nothing but minus pi by 2. So from the graph, it is also a solution, so it satisfies. So if n is minus 2, we'll get theta as minus 2 pi plus pi by 2, which is nothing but minus 3 pi by 2. Similarly, you can prove for all other values. So this is the correct equation. So that's the reason we are able to verify the all the values of theta. Why it is n pi over here? Because when you take the difference of these two values, it gives pi, like 3 pi by 2 minus pi by 2, which is 2 pi by 2, which is nothing but 5. Similarly, if you take the difference of these two, it is also pi. Similarly, if you take these two, it is also pi. So that's the reason we'll take n times of pi, where n belongs to all the integers. So when you take the LCM for this theta solution, you will get the final solution for theta as theta is nothing but 2n pi, sorry, 2n plus 1 times of pi by 2, where n belongs to integers. So this is the solution for the theta when cos theta is 0. Here, the other solution of theta you can write is theta is equal to 2n minus 1 times of pi by 2, where n belongs to integers. You can just verify this by keeping the values of n as 0, 1, minus 1. You will get the same answers what you have got over here. So both the solutions are correct. So the next trigonometric equation is cos theta equal to 1. So when you see cos theta equal to 1, or when somebody asks what's the value of theta if cos theta is 1, you will generally say, without much thinking, theta will be 0 degrees, because we know the basic, because we know this value before. But now we are going to see that theta equal to 0 degrees, it's just the one solution for this equation, because it has infinitely many solutions. So let's see how it is actually. So this is a cos theta or cos x graph in which all the radian values are on the x-axis and 1, 0, minus 1 are on the y-axis. So what are the values of theta when cos theta is 1? So 1 is 0, because this is the basic solution we know. At this theta value, the cos value is 1. Similarly, for 2 pi, the cos value is 1. Again, for minus 2 pi, the cos value is 1. If you observe the difference between 0 and minus 2 pi, the difference, okay, only the magnitude, it is 2 pi. Similarly, here also the difference is 2 pi. So we can write theta as 2n pi plus 0 because theta is 0, where n belongs to all the integers. Let's verify this or let's check whether this solution is correct or not. If n is 0, theta becomes 0. This is true because this is the basic solution what we know. If n is 1, theta becomes 2 pi. Is this correct? Yes, this is correct because from the graph cos 2 pi is also 1. Similarly, if n is minus 1, theta becomes minus 2 pi. Is this correct? Yes, this is also correct because at theta equal to minus 2 pi, the cos value is also 1 according to the graph. So we can write the solution for the theta when cos theta equal to 1 is, now the solution for theta becomes 2n pi where n belongs to the integers. So this is the solution of theta when cos theta is 1. The next trigonometric equation and the final equation is cos theta is minus 1. So if someone asks you what's the value of theta, if cos theta is minus 1, you'll just think for 2 seconds and just simply say that the value will say theta is pi. But this theta equal to pi is just a single solution for this trigonometric equation because it has infinitely many solutions. So let's see how it is. So this is the cos theta or cos x graph in which the theta values are on the x-axis and cos values, that is cos theta values, that is 1, 0, minus 1, are on the y-axis. So we know at theta equal to pi, the cos value is minus 1. This is the basic solution what we already know. So similarly, from the graph, we can say that at theta equal to minus pi, the cos value is also minus 1. If you see the graph again, like actually it's not over here, it's not there over here, but at theta equal to minus 3 pi also, you will see the value will be minus 1 somewhere over here. Similarly, at theta equal to 3 pi, you will see the cos value is minus 1, like somewhere over here. Like the graph, actually the graph is not present, but it is true. So if you see the difference between these two, it is 2 pi. How? Pi minus of minus pi, which is nothing but 2 pi. So we can write theta as 2n pi plus pi, where n belongs to integers. Why pi? Because we know the basic solution for theta is pi. Let's verify this. If n is 0, theta is pi, which we already know before. If n is 1, theta becomes 2 pi plus pi, which is nothing but 3 pi. I've already showed you over here. Similarly, if n is minus 1, theta becomes minus 2 pi plus pi, which is minus pi that we have seen in the graph. So this solution verifies all our theta values. So the final solution for the theta when cos theta is equal to minus 1 is, so the solution becomes theta is equal to, take pi common, it becomes 2n plus 1 times of pi, where n belongs to all the integers. So this is the solution of theta when cos theta is minus 1. The one more solution we can also write over here is theta is equal to 2n minus 1 times of pi where n belongs to I. You can even verify this. That is, for the second part, if n is equal to 0, we can write theta as minus pi, which is a solution we have seen in the graph. If n is equal to 1, we can write theta as 2 pi minus pi, which is nothing but pi. This is also a solution. If n is equal to minus 1, we can write it as theta is minus 2 pi minus pi, which is nothing but minus 3 pi. I already told you right here. So both the solutions give the same answers. So if you take anything from these two, you will get the final answers as the same. Final results are, if sine theta equal to 0, what's the solution for theta is nothing but n pi, where n belongs to the all integers. Second, sine theta equal to 1. If sine theta equal to 1, then the solution for theta is 4n plus 1 times of pi by 2, where n belongs to all integers. The other solution also exists for this. That is, if theta is equal to 4n minus 3 times of pi by 2, where n belongs to all the integers. Third, if sine theta equal to minus 1, then the solution for theta is 4n minus 1 times of pi by 2, where n belongs to all integers. The other solution is 4n plus 3 times of pi by 2, where n belongs to all integers. For these two, you can remember a trick. That is, if for positive value of 1, you are getting the positive value here. For negative value, you are getting negative minus 1. From these two, you can remember any one. So I'll suggest better you remember over this here, because you can easily identify. For plus positive value, you are getting plus sign over here. For negative, you are getting minus sign over here. Next, if cos theta equal to 0, the solution for the theta is 2n plus 1 times of pi by 2, where n belongs to all the integers. The other solution is theta is equal to 2n minus 1 times of pi by 2, where n belongs to all integers. You can remember any one from these two solutions. I'll suggest you to remember the first one because it is very easy. For cos theta equal to 1, the solution of theta is 2n pi, which in which n belongs to all the integers. And for cos theta equal to minus 1, theta is 2n plus 1 times of pi, where n belongs to all the integers. Or the other solution is 2n minus 1 times of pi, where n belongs to all the integers. So here also in these two solutions, I would suggest you to remember the first one because it's very simple and easy. So in the first and in this fifth one, if you see, for sine, it is just n pi, whereas for cos, it is 2n pi. Don't forget these simple things because it totally changes your answer. Okay? I hope you'll remember all these values and also verify them after getting the solutions by taking the values of n like 1, 0, minus 1 and so on. Okay? Because it just gives you a better idea and confidence for the solution.